We are continuing on part 2 of logarithmic functions. We stopped at the basic property last time, so let me just recall this. If I have log base b of 1, it is equal to 0 because b to the 0 equal 1. Right? You don't have to remember all of these. Just understand that log is exponents and the arrow, tornado arrow. B to the log base b of b. By the way, I have a habit of putting the parentheses around the argument. Whatever inside the parentheses, I call them argument. B to the first equal b. Makes sense. That makes sense. So far, so good. And then for the inverse property, if I have log base b of b to the x, the argument will be b to the x. Makes sense, right? B to the x equal b to the x. Or you can think of this as inverse function, right? Log base b is the inverse function of b to the x. When you put one in another, like I said last semester, last lecture, they cancel, right? Just x. And if you do just like this, like that you indicate to me that you cancel them, right? And will be good enough for me. B to the log base b of x equal x. This is log function. That is exponential function. This is f of g of x. The other one is g of f of x. Where g is my b here, f is my log. So here it's the reverse. I'm putting the log function inside my exponential function. So b to the blob. And again, because they are inverse, exponential and logs are inverse, cancel, just x. Let's evaluate some problems. 3 to the power of log base 3 of 6. The base are matched. You have base 3 here for the exponential and you have base 3 here for the log. So they cancel. Remember a composite function, right? So it just equals 6. Equals 6. I use yellow when I cancel thing. Can someone tell me what's number 2 equal to? If I don't write log, if I don't write the base for log, it's understood at log base 10, right? So because they measure log 10 to the log base 10, cancel. By the way, the only time you cancel when they have the same basis, okay? Hypothetically, don't write this down. If I have 5 to the log base 10 of square root of 5, I cannot cancel. Because the 5 and the base 10 here are not matching. They're not inverse. So equal root 5. What is 1 equal to? Ten to the what power? Give me 10 to the x. Or x. And then last but not least, e to the ln of x plus 1. I don't know if you remember. I think I mentioned this. Ln e equal 1. So note, this is note. Ln e equal 1 and e to the ln also equal 1. So e and ln are, remember they are base e, so cancel. So they just x plus 1. Do you have any questions so far? Here's the product properties and quotient properties and power properties.
What's up, ready?
If I have logs of a product is equal to the sum of logs. So if I have log base b of m times n, it is equal to log base b of m plus log base b of n. Get the extra credit out. I wrote on Moodle. Yeah, I wrote on Moodle. Now, b is a base, cannot take negative number or 1. Let me give you a little beware. Beware. I see this student do this a lot. Log base b of m plus n, it is not equal to log base b of m plus log base b of n. I know it's as much as it's tempted, people tend to distribute the log, but no, right? It's kind of like this. It's kind of like square root of a plus b. It is not equal to square root of a plus square root of b. Right? If you have square root of a times b, then you do square root of a times square root of b. So please don't do that on the exam. Okay? We don't have any rule that tell you when you argument is the sum, you make it into the sums of log. Right? If you have something like this on the exam, you just leave it like that. Nothing you can do. But if they're a product, you can split it into a sums. If a product becomes a sum, then the quotient becomes the difference, right? So if I have a log of a quotient, is equal to the difference of logs. Okay, so if log base b of m divided by n equal to log base b of m minus log base b of n. Same thing. Log base b of m minus n, it is not equal to log base b of m minus log base b of n. That's why I see students do all the time. It's very tempted to distribute the log, but it's not how it's done. The last rule is I call that a parachute rule. If I have log base b of m to the p power, I can parachute down. I can take the p down, but take the power to the front and multiply to the log. That's why I call it parachute. Take the p to the front and then multiply to the whole log. All right, let's apply some. I have log base 4 of 6 times x. This is the product, right? So according to the product rule, I can make into the sum of logs. Okay? So this is equal to log base 4 of 6 plus log base 4 of x. And you say because log base b of m times n equal log base b of m plus log base b of n. I just literally rewrite the rule for you. This one become a difference, right? So log base 5 of 5 minus log base 5 of 7. Am I done here? Am I done here? And you say because log base b of m divided by n equal log base b of m minus log base b of n. Can I simplify log base 5 of 5 equal what's log base b of b? Equal 1, right? So log base 5 of 5 equal 1. 5 to the first equal 5. Right? So this one become 1. So 1 minus log base 5 of 7, nothing I can do. This one, 2 different bases. Now you're done. Number 3, there are 2 ways for you can do this. The short one and the long one. They should give you the same answer. It's a parachute rule, right? You have power, it's a parachute rule. So I can bring the 2 to the front and multiply to the log. So 2 times log base 3 of x. So far so good, and then you're done. And then you say because log base b of m to the p is equal p times log base b of m. Another way of doing this, maybe I'll show you. I can write this as log base 3 of x times x, yes. Right? If you have a product, you can make into the sum of logs, right? So it becomes log base 3 of x plus log base 3 of x. It's kind of like x plus x is equal to 2x, right? So 1 log plus another 1 log, and they the same thing. So it becomes 2. 2 log base 3 of x. You see the same answer as you have here. So either way, you have the same answer. Last one. Ooh, last one. Hairy one. Something like this on the exam might be. All right, let's do one rule at a time. I would use quotient first. I would use quotient rule first. So this equal to log base 5 of x squared y to the 4 minus, I'm going to put the bracket there because the minus applies to everybody. And I'll tell you what are everybody. Who are everybody? Log base 5 of 25z. So I applied the quotient rule first. And now I'm going to apply the product rule. So log base 5 times, well, not times, sorry. Log base 5 of x squared plus log base 5 of y to the 4. So far, so good. That's for the first log. That one. And then for this one, minus bracket log base 5 of 25 plus log base 5 of z. I'm doing slowly. Next, I'm going to use parachute rule, the power rule. I can bring the 2 to the front. So 2 times log base 5 of x. And then do the same thing for the log base 5 of y to the 4, right? Plus 4 times log base 5 of y. I'm going to distribute the negative to the second bracket or the bracket. So minus log base 5. Instead of writing 25, can I write 5 squared? Minus log base 5 of z. Distribute that negative. On the exam, I do want you to simplify the answer completely. Okay, so for example, here I can cancel log base 5 and the 5. Okay, so just a 2. Just 2 here, so minus 2. And then bring everything down. The rest, I don't think you can simplify any further. That is a long way. You want me to show you the shortcut? Here's the shortcut. But as long as you understand the shortcut though, then I'm okay with it. The shortcut is this. When you look at the argument, when I say argument, I meant this. The input of log. That's your argument. Right? That's the base. It's not argument. That's the base. Whatever factor on the top is going to have the plus. You're going to have a positive log. The factor in the bottom have a minus log. Right? So for me, I do this. If you're comfortable with log, you would say, let me rewrite the problem. Okay, log base 5 of x squared y to the 4 divided by 25z equal, the factor on the top going to have a positive log. So positive there. Log base 5 of x squared plus log base 5 of y to the 4. And then the factor on the bottom have a negative log. Right? So minus log base 5 of 25 going to be same thing as 5 squared. Okay. Minus log base 5 of z. And then you cancel this one to have a 2. Then you bring everything down. Like that. Of course, you don't write the plus here. You don't write the plus to the first term. Right? So that's the shortcut. Which one you like better? For the exam, you probably like the shortcut. But that's the shortcut. It comes from the long method. Same answer. Oh, you have to distribute the. Sorry, you gotta distribute. I forgot to distribute the power down. So 2 here and then 4 here. Done. All right. For those of you who are here, I'm going to give you a bonus point. Write this on your exam. OMSU. So that's a bonus. So plus 1 point, just automatically. You wrote that above 1 point on your exam. Yeah, just say go MSU, and I know that I'll just automatically add it. Or you know, go Spartan, whichever you prefer. Something MSU. All right. Not posting it online. So. Let me put theirs in case people ask me again. All right, so let's use that to continue doing problem. Either I can ask you to expand the log, or I can ask you to squish them together to make into one mother log. Right? So if I start out like this, meaning I'm asking you to expand it. Of course, people from Zoom, if you, I know that you're here, but whether you actually listening to me or just turn it on and leave it like that and do other things, I cannot. If you don't have this on your exam and you say, Mimi, I was there that day, you're supposed to catch this. Okay, I'm not supposed to remind you. Right? Here, it doesn't matter. I'm not taking attendance, so it means nothing to me. You study is yours. Your study time, you're supposed to study. All right, so let's expand this. Should I do the fast way or the long? Let's do the fast way because I don't have enough space here. All right, so ln, remember the factor on the top, get the plus log, right? So ln of x, right, of course, it's times here. So plus ln of square root of x squared minus 1. Instead of a square root of x squared minus 1, you know, I'll leave it like that for now. And then the one in the bottom, get the minus log, right? So minus ln of e to the x. What's ln of e to the x equal to? Remember, what's ln e equal? 1, right? 1, so just x, right? So that drop. Ln and e, the inverse, so they cancel. So just x. Another way to think of it like this is ln e to the x is the same thing as log base e of e to the x. Well, e to the what power give you e to the x? X. We cancel. Okay. All right. Another question for you. Can I split ln of square root of x squared minus 1? Can I write like this? Don't write this down. Can I write like this? This one become ln of a square of x squared minus square root of 1. And then what you do next is you do this ln of square root of x squared minus ln of square root of 1. That is just wrong. Right? I cannot give you any partial if you do that. You cannot split. Like I said, beware earlier. There's no rule for log of the sum or log of difference. What you can do best is I'm going to rewrite square root in terms of to the 1/2. Is that okay? So this right here, I don't want to rewrite the whole thing, so I'm gonna do like that. The same thing as say taking square root, right? On the exam, when you see square root, when you see cube root, I want you to automatically rewrite it as rational root, right? To the 1/2, to the 1/3, something like that. The reason you do that because you have to use another rule. It's called power rule. I can bring the 1/2 to the front. So 1/2 times ln of x squared minus 1. Bring down the first term. Am I done here? Am I done? Thank you, Lexi. I'm not sure which one you're answering. Oh, you meant x, not 1, right? Oh, you meant ln e. Okay, thank you, Lexi and Hannah. Am I done here? People from home, you can answer in the chat box if you want. You don't have to speak it out loud. You don't want to.
Is that supposed to be 1/2 times ln or 1/2 ln?
1/2 times ln.
Thank you.
Yeah, it's the power rule. The power is supposed to multiply to the log. The question is, am I done here? Can I box it? Well, you can do term by term, right? ln x, nothing I can do, right? The last term, negative x, is nothing I can do. Now the middle term, I do not want to see you guys split it into ln x squared minus ln 1. Right? That's what I don't want to see. Remember the rule I keep. Remember what I shout out here, right? Don't do that. So leave it like that. Nothing you can do. Be done. And I'm gonna keep saying that many, many times because I'm really tired of grading exam people do that in the past. Any question before I move on? My Zoomer, do you guys have any question before I move on to 6 and 7? All right, so that's expanding log. Now we do the reverse engineer combined log. Right? Now I just want one mother log, right? One big log. Then you reverse the process, right? You reverse the process. Remember here, you do the power rule last. Right? You do the power rule last. Now when you combine, you do the power rule first. So now I'm gonna put the power back. So put the 3 backs, put the 1/3 backs for the z, put the 5 back for the argument. So equal logs. It's base 10, so I don't write anything. Logs of x cubed plus log y minus log z to the 1/3 minus logs of x plus 1 to the 5th. Let's use a shortcut. Remember what I say? Positive log stay on the top, right? Negative log stay on the bottom. So log. What numbers stay on the top? No, only one log. X cubed, right? And then y. What's there on the bottom? Z to the 1/3, or you want to write cube root of z is fine. And then x plus 1 to the 5th. Are you comfortable with me doing that? I did that before, didn't I? Just reverse. Remember, I did the shortcut, the shortcut right here. Like I said, right? The factor on the top gonna have a positive log, and the factor on the bottom have a negative log, right? I just do the opposite. Just reverse the process. Number 7. Can someone tell me what number 7 is? Should be one shot, one line. I waited till this moment to tell you. I cannot do this in the lower class. They don't understand. But yeah, we multiply them, right? Remember, sums of logs become the log of products. Right? So log of C times A times B times I times N. Again, I keep reminding you this, so you remember why I do what I do. Log base B of M plus logs base B of M. Here you go from right to left. You can do either way. On your exam, you probably have something like this, either expanding and or combining logs. All right, another rule is called change of base property. If I have log base b of m, again, m is your argument. Earlier, I told you that you can just stop it right there, right? But you can do more if you like. It's not necessary. It's just necessary when you have a numerical value. What you can do more is it is equal to logs base 10 of m divided by logs base 10 of b. So the b is in the bottom. Or you can do ln of m divided by ln of b. You should have just two same answers. And let me give you an example why this is true. Can someone tell me what log of 1,000 equal to? Three. You agree? Do you agree it's equal 3? Yes or no? Yes, right? Log by 10 and the 10 cancel. Right? Now, I'm gonna use the rule. You change of base property. I'm gonna rewrite this. It's gonna be equal to. So let me rewrite the problem. Logs of 1,000. Again, this is log by 10. Right? Log by 10. So it's gonna be equal to log of 1,000 divided by log of 10. Yeah. 1,000 is your m, 10 is your b. Log m divided by log b. What's log 10? Log 10, 1,000? Which is 3, right? What's log 10? 10 to the what power give you 10? 10 to the first, right? Well, they cancel, right? So 1. So here is 1. And you can just cancel. They're the same thing. You cancel. Yeah, so 1. So 3 to the 1 is still 3. Nowadays, that rule is not a problem. The reason you have this rule, because back in the day, your calculator only had log base 10 and log base e. Right? They don't have log base 2, they don't have log base 3, other bases. Well, if I have log base 2 of something, how do I calculate that if I don't have log base 2? Right? So one way they can cheat it like that, right? So for example, don't write this down. If I have log base 2 of 5, for example, either you look at on the table, back in the day, they had a little book. They have all the bases there. You actually look through it. Or you can use a rule. Or either way, you have to look it up. Log 5 divided by log 2. And your calculator have log base 10, right? So all you do is log base 10 of 5 divided by log base 10 of 2, and it'll tell you the answer. But nowadays you have a more sophisticated calculator. You don't need the rule much. But sometimes we do use it, especially in the proof mathematics, not competition wise. All right, number 1. Let's go back to number 1. Can someone convert this into the formula for me? It will be log of what divided by log of what? Yeah, by log of 2, right? Or you can do ln of x divided by ln of 2. It's the same answer. Thank you, Michael. All right, so that change of base, even though for computational y is not it's not used as much as nowadays, like it used to, but we still need it. Here is the summary of log, all that I show you. I'm not giving you this on exam. You're supposed to know that. To be honest with you, I remember none of them. I just kind of know it. You do a lot of homework, you know what to do. As long as you understand it, don't memorize it. But if you have to memorize it, then go ahead, do so. Let me give you some more. Let me use it like one more. I was called, that's 5-ish. Is related to ln. ln E equal 1. You know, 5, 5a. Let's do 5a. ln of e to the x equal x, right? Remember, ln and e, they inverse, they cancel. 5c. E to the ln equal 1. And 5d. E to the ln of x equal x. Cancel. That's why you have that rule. Right? So you see the different ln and next to, this is a log, this is the exponential, so they cancel. When you do the exponential, you want to cancel the exponential here, and then you should have a power here, and the power is a log, base e. Right? So remember ln e1, but e the ln is 1. Let's solve some log prof equation. Start out with the easiest one. Well, it's not the basic. The basically you have a log on one side and then a constant on the other side. Let's start with this. All right, here's a rule when you're solving log equation. Whatever they give you, each side you should have just one log. And I'm talking about linear log. Right? Meaning what? Whatever in front of log, use whatever properties you need to use to get rid of the 2. Not like disappear, but move it to somewhere else. So the 2 has to, what rule am I using? The power rule, right? I can put it back. So I can have the left-hand side, rewrite it. On the right-hand side, it's going to become log base 4 of x squared now. That's what I meant by linear log, right? Nothing around it. Nothing around it, nothing in front of it, nothing below it. Well, except for the base, but that's part of the log. Now they lean, now they good. Let me ask you a question. If I remember, I taught you if x squared equal, if 2 to the x equal 2 square, this imply what? X equal 2, right? Let me do cute here because what 2 you're talking about. So this imply x equal 2. Well, this is an equation. Log base 4 of 24, it has to be equal to log base 4 of x squared. If I take 4 power both sides, if I take 4 base 4 both sides, I'm canceling this, am I? Right? You remember that? B to the log base b of x equal x. Then you cancel. Or the inverse of one another, they cancel, right? 4 to the exponent something, and then log base 4 is the inverse of 4, so they cancel. When they cancel, now I have 24 equal x squared. Want to solve for x? X equal plus minus square root of 24. What's square root of 24 equal to? 4 root 6, 2 root 6, right? Anybody see that? Or should I write more? It doesn't matter, really. I'm not really important to me. You have to do that. Now, for log function, you must check your answer. You must. It's part of your credit. So here I have either x equal positive 2 root 6 or x equal negative 2 root 6. If you would have plugged that in your calculator, what happened? Let's do that. Let's do that. So I have logs base 4. How do I go to log base 4? I forgot now. Oh, right here. You go to math. By the way, you go to math. 4 button down from the left. You go to math. And in the first option, math, you go all the way down to log base. Go down, down, down. Right there, log base. Press enter. It's base 4. And then it's 24. So equal to 2.29 something. I want to check if log base 4 of square root of 24 is the same thing, right? So math again. Either usually I go I use the upper arrow, so flip it so it's quicker. Log base 4, and here's square root second x squared square root of 24. Oh, something wrong. Log base 4. Oh, there's a 2 in front. Sorry, that's a 2 in front. My bad. The right hand side is 2 times log of x. Let me do it again. It's wrong. Let me do it again. So 2, and then base 4, and then x is square root of 24. Yes, right. They are the same answer, right? 2.29 something, 2.29. So the positive case is work. So we pick that one. What about negative one? I'm be lazy. I'm gonna put second entry. Spit it back the one that I just did. The second entry, second, and then the enter. That's the last entry. I'm gonna change it into negative square root of 4. You want to put the I'm sorry, it's you can't see because of the screen. You put the opposite key, don't put the minus key. It's not gonna work. What is that? Well, it's not 2.29. I know that. So you cannot pick the answer, but what can you see what it is? What did it give you? What kind of solution is that? Is it real or imaginary? Imaginary, right? So I know that is not it. Okay. We talk about real here. Extreme solution. The only solution you have this one. You can remember the domain of log. The reason we picked that, let me remind you. Did I tell you the domain of log? Oh, I didn't. Oh, I did. Look at the domain of log, the one in blue, from 0 to infinity, right? It doesn't take negative value. The next one. Is my logs, are my logs lean? Nothing in front of it, nothing below it, right? So it's lean, right? It's clean up, it's clean. All I have to do is cancel the log 5, right? They did the same thing. The reason we cancel because we took base 5 to both sides, and then we cancel that. On the exam, if you just do like that, it's fine by me, right? It's fine by me. But the reason we would be able to do that because of that. Right? So this become 4x minus 2 equal 10, 4x equal 12, x equal 3. Is x equal 3 check? You're gonna check, right? Yes, it is, right? Logs base 5 of 4 times 3 minus 2, it is equal to logs base 5 of 10, is equal to the right-hand side. It's equal to the right-hand side, so check. Let me see, so I checked my answer there as well using calculator. All right, so that's easy. What I just gave you is just one log at each side, right? What if I have 2 logs on one side? What I don't want to see is this. Don't write this down because this is what students do. But half the class last time, they would do this. I wish it was. I wish it's just that easy. But no, right? There's no rule allow you to drop a log like that. I said, Mimi, you told me to drop a log. Well, I told you to drop it if you have what? One log on each side, right? And they have to have the same base, right? You have same base, but they're 2 separate logs. Right? You cannot drop. Yes. Go ahead. If you move to the other side, don't write this down. So I'm just explaining thing here, like what students get wrong. If I would have do like this, subtract log of x plus 2, is that what you tell me? Oh, the other one. Okay, let's do the other one. But I'm glad you asked. I want to know what you think in your head, so I can tell you not to do that. So that's cancel, right? Don't write this down. It's not how we do it, but I want to show you. You still stuck. Remember what I say. You have one side, one log on this side. You don't have just one log on that side, but is that log clean? No, it's not clean, right? It's being attached to the one, right? Even worse than the being multiplied, right? So either way, you move things around, you still stuck. Right? Do you guys remember the rule you can do? How do I combine those 2 logs? Product rule.
Well, it helps visualize, all that right together. At least we're doing that.
So do you remember that rule, right? So what you see here is this one right here. That's the right hand side, right? You want to convert it into a single log. You want to combine it. So what multiply what? Log of x times x plus 3. Like that, right? Like that. Now you have one lean log. Can I distribute the x? Yeah. X squared plus 3x equal 1. Now we don't know how to solve a log function, but we know how to solve an exponential function. Now you have a log on one side, but you have a constant on the other side. You don't have another log on the other side. That's okay. Remember the tornado arrow? Remember that, right? So I can do 10. I can do 10 to the first equal x squared plus 3x. Remember, your goal is to solve for x. Right? You do whatever it needs to be done to, clean it up a little bit. So you have some similar form that you know how to do. In this case, quadratic. Everybody know how to solve quadratic. Even though you don't know how to factor, you can use the formula. I'm gonna move everything to one side because it's quadratic. Can you find two number, multiply -10 and add to 3? Mike, by the way, I muted you, so I don't want you to, keep talking. You're thinking that you're not mute. You accidentally unmute earlier, so I muted you. So if you want to talk, you have to unmute yourself. 5 and 2, right? +5 and -2. Looks good. Yeah. So either x equal +2 or x equal -5. Which one do I cross out? -5, right? Now, it's not because it's the negative solution. Sometimes negative solution work because when you plug it in, it's undefined, right? It gives you imaginary. Sometimes if I have this, hypothetically, if I have this, like log of -x, equal to, and then you solve for x. X is -100. This work, right? It works, right? It works. Don't write this down. I'm just saying that it's not because negative is you always cross out. You gotta plug it in, right? In this case, it works because what happens when you plug it in is log of -100 to become +100, right? So even though it's negative, it's not always like just automatically cross out. The reason we crossed it out because when you plug it back, it's undefined. In this case, it does, right? Log to the -5, that's bad news. We cross out. When you do that, I know that you check your answer. You don't have to show me all the work. Right? On the exam, I'll give you a problem where you have to cross out one of the solution. Right? Then I know that you check your answer properly. So far, so good. Is there any question? Well, I'm gonna move on before I need to move on. All right. So here, I have multiple logs. Right? Remember what I said in the beginning. You need to have one log on each side only, right? And those logs have to be clean. I can use the quotient rule, right? Let me recall. Log of m divided by n equal log base b of m minus log base b of n. So this becomes logs of x to the 4 divided by 5x plus 12. Remember the positive log have the factor on the top. The negative log have the factor on the bottom. Negative logs of x, it is the same thing as -1 times log of x. Can I move the -1 to the power? So this whole thing right here, I'm going to move it back to x. So it become log of x to the -1. Now I have one log each side, and they all lean, they all clean. Okay. What the base here? Base 10. Right? So you can take base 10 to both sides, or you know what? You don't go ahead and just drop them like that. I'm good. So this is implied x plus 4 divided by 5x plus 12 equal x to the -1, and the same thing is 1 over x. Right? So far, so good. You guys know how to solve for that, right? LCD will be 5x plus 12 times x, but let's just cross multiply. Let's cross multiply. What I meant by kind of like that, right? It's easier. So I have x plus 4 times x equal 5x plus 12 times 1, which is still 5x plus 12. X squared plus 4x equal 5x plus 12. It's quadratic, so move everything to one side. Now I have x squared minus x minus 12. Don't worry, on the exam, I'll give you something that you can factor. You don't have to use quadratic formula. 4, 3, negative 4, positive 3. So either x equal 4 or x equal negative 3. Well, we can cross out the negative 3, right? Because when you plug into the right-hand side, negative logs of negative 3, that's bad news. Negative argument is bad. Is 4 check? Sometimes they, sometimes they don't have a creative solution. You gotta check, okay? Check both. Doesn't mean that you just automatically pick this one. Sometimes they have no solution. I can trick you into those two never equal this in the first place, right? Let me give you the happy ending. I check it at home. We checked. But you gotta check it, okay? We continue this next time. Your extra credit, I'm going to extend it until near midnight tonight, okay? So like 11:55, something like that, or 59. Let's see what the option, but near midnight. All right, if nothing else, have a wonderful weekend. Be safe, and I'll see you next week. Hang in there, one more week. Just bear with me one more week.
I have a question.
And then we can do it.